सही है, बिस्मिल्लाह करें।
चलिए जी शुरू करो यार।
बिस्मिल्लाहिर्रहमानिर्रहीम। अस्सलाम वालेकुम रिस्पेक्टेड सर।
इधर आप खड़े होंगे तो तब उधर दूसरी
I
साइड
thank
पर
you so
आवाज़
much for inviting me for defense presentation.
अस्सलाम वालेकुम सर।
My name
अब
is
मेल के में सब ताश लिंक दरो ले गलू जी ए बांधे क्लिक कीजिए। आओ जी आओ व्हाट्सएप ना आप कार ना कहीं तो कम इधर आ जाओ इधर करो।
My name is Naem Ullah. My supervisor name is Dr. Said Irfanullah and co-supervisor name is Arbab Ullah Khan. My presentation topic is performance evaluation of digital algorithm in SDN controller. The title of research is Performance Analysis of POX in Rio based on the Dijkstra algorithm for software-defined network. The author name are Naemullah, Dr. Irfanullah, and Dr. Abdul Salam, Arbab Wajidullah Khan, and Muhammad Imam, which is published in Turkey EAMMIS 2021 Springer Conference.
मैं इधर उसको अलाउ कर देता हूँ तमरीक को। चलो इधर खड़े हो जाए ना, सर को आवाज़ चाहिए। खड़े हो जाए, बोल अब बोल।
The title of paper is Performance Analysis of POX in Rio based on digital algorithm for software-defined network. The author name are Naemullah, Dr. Said Irfanullah, Dr. Abdul Salam, Wajidullah Khan, and Muhammad Imad, which is published in Turkey EAMMIS Springer Conference in 2021. These are my presentation outline: introduction, literature review, problem statement, research objective, methodology, results, conclusion, reference. In this slide, I would like to introduce basic background of SDN. SDN stands for Software Defined Network. SDN is a network framework that allows network administrator to dynamically and automatically control, manage a large number of network devices topology using high-level language API. Also, SDN separates the control plane from the data plane. SDN architecture consists of three layers: application layer, control layer, data layer. Application layer is an open area to develop as a much innovative application. Control layer is responsible for exchanging the routing information to the forward plane. Controller is the core object of SDN, which accepts specification or order from application layer, then implement in the data layer. SDN controller consists of different controllers like POX, Rio, Floodlight, OpenDelight, Trema, and etc. Comprehensive overview of related topic which researchers have already been working on it. In the first paper, the researchers have evaluated 5 SDN controller: NAS's OpenDelight, POX, Deployed, and Beacon. They compare these controllers to find the best controller among these 5. Finally, they achieved the Deployed controller had the highest delay compared with the other controller and the lowest delay volume for the NAS's controller. In the paper number 2, researchers have compared OpenDelight with Floodlight controller and implement Dijkstra's algorithm for finding the shortest route. Finally, they achieve the floodlight is better than open daylight. In paper number 3, a researcher implement two algorithm, routing algorithm, round robin, random, and SDN POX controller. They use the algorithm for the purpose of finding the shortest route. Finally, they achieve the round robin distribute load reasonable compared to random algorithm. And also they give the future work use other controller and other shortest path algorithm.
Naemullah,
Yes, sir.
what is this random algorithm?
The random algorithm is used for finding the shortest route.
Not used for. What is? How this random algorithm works?
This, when they want to find, when packet arrive to the network, they find randomly.
Randomly what?
On the basis of random and the mechanism of random.
What random? Can you find a path randomly?
On the basis of random procedure, it will.
Do you know what do you mean by random?
It is written over there
What?
to the well-known shortest path.
Will known shortest path.
So just look at there and answer.
No, इसमें दो है ना ये
Yes.
कहते हैं कि ये round robin and random algorithm implementation to find well known shortest path, तो इसकी comparative study है round robin और random algorithm को compare की तो random algorithm कौन सा है जो कि shortest path find out करते हैं and how it finds a shortest path?
This is the procedure in routing protocol we use for routing, sir.
Which procedure?
No, this
Sir.
question is there.
Yes.
What is the random algorithm? Difference between the random algorithm
And round robin.
Round robin algorithm. Very simple. Very
Simple.
simple answer. One line answer.
Okay.
Not the detailed about the how this algorithm works. Very simple. How they differ with each other. This is the question.
What is round robin?
Round robin and work on the to find the shortest routes on the basis of flooding techniques.
Globe? Flooding?
Flooding techniques.
What is flooding?
Flooding means when
Flooding
packets
means round robin and round robin means flooding.
when packets arrive to the network, it distributes to all outgoing paths.
अब तो सामने खड़े इधर अब समझा दो उधर तो अफगानिस्तान था ना आवाज सही नाराज हो दान लेके उस मखामख थे उससे पोई क्या करना
In the second paper, the researcher implement POX controller and compare POX and floodlight controller in mininet environment to explore popular known controller. Finally, they achieve floodlight much faster than POX controller. And number 5, comparative study on load balancing algorithm in software-defined network to find the shortest route. Finally, they achieve the flow statistics-based algorithm show better response time to comparison to other. And they give the future route to use Rio controller and other shortest path algorithm. And the paper number last, performance comparison of floodlight, beacon, open mule, and open IRIS controller to discover base controller, comparative study. Floodlight is base controller on the basis of latency among these.
Why floodlight is best?
Floodlight is based on the on the basis of different technique. Floodlight throughput is better, and latency time it take for packet
What is
transfer.
latency?
Latency is delay, similar to delay. Delay time taken for packet when packet is transmitted, when it is received. This is called latency or delay. Problems are made. A lot of researchers have worked in this area. but still remain there some difficulties to find the shortest route in SDN controller. And to find I want to implement the digest algorithm in SDN POX controller, and additionally the optimal controller for applying this algorithm on the base of different network performance parameter. To achieve above mentioned problem, this is my objective, to simulate the traffic behavior and evaluate the network performance based on regular algorithm, and to also to identify the best application traffic route based on throughput, PDR, jitter, and packet loss. Next, this is my proposed methodology. There are a number of steps involved in our proposed methodology. First step is the selection of shortest route algorithm. For shortest route, we select digest algorithm. Then I select the SDN open source controller. I select two open source controller, POX, Rio. Finally, I compare POX in Rio on the basis of network performance parameter like throughput, PDR, jitter, and packet loss. Performance parameter is throughput, PDR, jitter, packet loss. Throughput means how much data can be sent within specific time. And PDR means packet delivery ratio, the total amount of data packets arriving at destination divided by total amount of data packets sent from source. Jitter means variation of end-to-end delay. Packet loss refers to the data packet that do not arrive at destination. This is my proposed algorithm to find the shortest route between source and destination node in SDN.
Is it your algorithm?
Is proposed algorithm for finding the shortest route for finding the shortest route between source and destination node of SDN controller. Initially, algorithm evaluate the first node of the network. The distance of the first node must...
Do you claim that this is your algorithm? You have designed this?
Yes, I designed.
From scratch?
Yes.
What modifications we have? This is digest algorithm.
Digest algorithm.
What modification on which number of line you made the modification? Like this, from 1 to 14. Which line is new?
I not modify, I implement digest built-in algorithm in...
This is not your algorithm.
Yes,
What are you
yes.
talking? Yeah?
Yes, okay, sir.
Sure.
The initially algorithm evaluate the first node of the network. The distance of the first node must be equal to the 0. Then add it to the next slide. Yeah, yes.
What is U and V?
U is the source node, the node of the network. U source and destination node.
And where are all the nodes? Where you have stored
All the node we store in the T. T state T.
T.
T, yes.
T contains all the nodes.
All the shortest node.
No, where are all the nodes?
All node, U in V the node that want to communicate to each other.
U is a source node and V is a destination.
Destination
right?
node. Yes.
And there are other nodes.
Adjacent nodes.
Adjacent
between
node.
two
And where are
those?
all the other nodes stored in this algorithm?
Yes, I want to discuss the same next.
Do you have another node?
Yes,
or
yes.
Just you have only
no,
two nodes.
No, sir. A lot of nodes.
Where are the nodes?
But I didn't mention there.
Where
This is the algorithm.
It's the algorithm.
No, where
In
should
the
we have
algorithm, you do
I
not mention
mentioned,
this
sir.
is generalized. It is
I
showing
mentioned,
the
sir.
picture of all.
Yes, okay, sir.
We have a set of nodes. In those set of nodes, then we have to find the shortest
No.
path from one node to another.
To another one.
Where are the set of nodes?
Sir. Yes, okay, sir.
No set of nodes.
Number of.
He
In
is
all
asking
possible.
you the question.
Yes.
And line number 6,
Yes.
find U not in T. Find U not in T.
You consider
U is already in the T in line number 4. U is already in the T.
now I consider U is the neighbor node of
Where
T.
you have written that there is a neighbor node. And from where you are finding the neighbor node. And on the basis of what parameter you are finding the neighbor node.
From the source node, yes.
Do you understand this algorithm?
Yes, sir.
You copied from somewhere else.
I understand. I implement in Python this, sir.
Do you understand what is written? What is U? What is V? What is capital T? What is capital L? What is T is equal to the line number 7? T union U.
Yes,
What
yes,
is
sir.
small U? What is
Small
small
u.
U?
UV is the node.
What is the capital U and what is small U? Very simple answer.
Capital U there is a union to add to the T. When I visit the node, then add to the set T. This U means
No,
union.
if you see the input number of N,
N number of N input
N nodes,
N
all
nodes.
possible paths between capital U and
U.
V.
NV, yes.
Okay? So there is from source node to destination.
Destination node.
Where are the adjacent nodes between these U and V?
UNV, yes. Okay.
Yes.
Where?
Adjacent node is the UNV, sir. But V and U is vector. VU is vector.
V is vector. Input.
Input.
Input number of N. What is
N.
number of N?
N number of input
What
node.
is number of N?
Number of N means, nodes. When you say that,
Can you see number of nodes? N is the number of nodes.
no server side.
And line number 2, you have written that L parenthesis V.
Yes. No.
Can you see?
Yes.
Line number 2,
Yes.
for all V is not equal
Equal
to
to
U
U
such that L parenthesis V.
V.
What do you mean by L parenthesis V?
L parenthesis means the distance of vertices. That is
What
equal
is vertex?
the distance of vertices.
What is vertex in the graph?
Vertex is a node in graph resistance.
And what is
And-
that?
And WUV means the cost between two vertices.
Okay. Now that makes sense.
Makes
So you
U
need
is
to
now-
say the capital U and V are the source and destination,
Destination.
and the small U and V are the adjacent nodes.
adjacent node.
No. How? कहाँ से ये adjacent nodes आ गए?
यही तो बता रहा है मुझे.
दिस इज स्पेलिंग मिस्टेक. कहीं पर अपर केस है, कहीं पर लोअर केस है. ये ऐसी कोई कन्वेंशन नहीं है कि अपर केस का
ये
मतलब
ठीक
ये-
बता रहा है.
नहीं. इट इज जस्ट
अच्छा चलिए ये बता दें ये बड़ा यू और बड़ा बी इस्तेमाल कहाँ हुआ है
Bada U, sir, is the union.
यूनियन है.
Where is it used?
Used to add to the
Used in your algorithm, where have you used it?
इनपुट में जो आपने यू एंड
in
बी
line number 7.
लाइन नंबर 7. लाइन नंबर 7 में तो लोअर केस यू है.
Lowercase u is node of vertex of the network.
बीच में
and
सर यू जो है उसको यूनियन कह रहा है
union.
तो ऊपर
Capital U is the
सर वो
union.
यूनियन को यू कह रहा है वो यूनियन
तो आपका सवाल तो ये था ना कि अपर केस यू कहाँ इस्तेमाल हुए हैं. तो ऊपर तो वो नोट था और नीचे आके वो यूनियन हो गया.
यूनियन के निशान को सर ये कह रहा
There
है
are plenty of nodes available for digestion algorithm. Why didn't you use the different, names or means
I use the
alphabets for the small,
Small
for
and
the
capital,
adjacent
for
nodes
adjacent
and
node.
for the source and destination.
okay, sir, I use this.
लाइन नंबर 3.
Number 3.
What do you mean by this?
Distance of vertices. Initially, the algorithm evaluates the first node of the network. The distance of the first node must be equal to the 0 in the initial.
This is the starting node.
Starting node, yes, actually starting.
No, starting node 0 के equal क्यों?
Distance is 0.
Distance, the
Distance.
इसका distance कहाँ से distance? For distance you need 2 points. Always for distance you need 2 points. The distance between 2 points. So where is the other point?
Algorithm first search this node, sir. The distance must be equal to the 0. Then the neighbor node. The neighbor node also have the distance.
Where is the neighbor node? And from where that neighbor node
is
coming?
V.
Neighbor node कहाँ से आएगी?
When you evaluate the first node, then add it to the first node to the T, set T. Then analyze the neighbor node of
From where?
from the input of the network.
Where is the input?
Number
Where
of
do
node,
we-
number of node.
And
In-
how do we know this node is neighbor and this node is not neighbor?
And there I consider U and V as the node. U is the initial and we are the neighbor.
You and we now.
Uh,
Neighbor node.
Neighbor
After taking
Yes.
the U as the initial,
Initial node is the U.
then you are adding the neighbor node. If there are more than one nodes, how do you will select the neighbor node? If this is neighbor node and this is not neighbor node, what is the parameter of selection?
In the first step, U is the initial node, the V is the neighbor node. When
You said V is the destination node. Now you are saying V is a neighbor node.
in finding the shortest route, sir,
Line number 9 and 10, you are adding L of U plus W of U.
if
So what is L and what is W?
L U and LV means the distance of one node, and WUV
Distance
means
of one node.
one node.
What do you mean by distance of
I
one
can
node?
write on the
Yes, please.
There is a graph.
Yes. Now that's good.
Initial node is U.
अच्छा
The
एक
distance
मिनट अगर तुमने अगर हाँ इनको कनेक्ट किया
2,
राइट
3, 4.
इसको भी कनेक्ट कर
You can, yes.
इसको भी कनेक्ट कर चल अप्लाई द लाइक दिस
Initially, algorithm evaluates this node. The distance of this node is equal to 1, 0. Then, algorithm evaluate the neighbor node of this node. See which node is the distance of
Neighbor
less than
nahi.
or equal to
Listen, not
Yes,
neighbor, listen,
yes,
adjacent,
adjacent node.
not the neighbor.
Neighbor, adjacent node. Analyze the adjacent node. The adjacent node distance must be equal or less than the neighbor. The second neighbor node. In this cube, we see which is the distance, 3 is distance. We select this is the neighbor node. When the algorithm this analysis added to the safety. First, you also added the safety. Then added to the beta t. For the remaining node, algorithm, for the remaining vertex, algorithm implement this condition. If the distance of this node is this one, the adjacent node of the previously evaluated node is greater than the distance of U initial node plus the cost means 3, 4. For example, this is infinity. From this side is 7 and from this side also 7. This select this part. And W means U, V. And the cost of these in this is called W, U. Then update the LU, the distance of vertices is equal to the distance of U plus the cost of U in. And repeat this T for the remaining node vertices adjacent node of the level. Oops, sir. Result. In this section, I want to discuss the POX in Rio controller throughput. Table show the time interval and the throughput of POX in Rio. First, the time interval between 0.0 and 1.0 second the Rio controller throughput in Digista algorithm is 7.16, and the throughput of Rio in normal flow 5.01 gigabyte per second. Now in Digista algorithm in POX controller throughput in Digista algorithm is
What do you mean
13.
by normal flow?
Normal flow without Digista algorithm implementation in controller.
So how you compute the shortest path? You just
Yes, good. When I ran the
digest algorithm used to calculate the shortest path.
calculate the shortest path,
So if you don't calculate the shortest path,
Uh,
so
in normal flow they use other protocol like open flow protocol for sending the packets for finding.
those are the protocols, not the algorithms.
Which one?
What are the other algorithms against the digester?
Register is for finding the shortest route in Rio controller. In normal, by default mechanism which built in from the company, reuse for finding the packets from source to the
You
destination.
mean to say they don't have an algorithm where they need to compute the shortest path?
In Rio, with a use
इसी
strategy,
तरह ये है कि मतलब कि-
use
Rio to
open-
simulator
open.
है, POX, these are the
नहीं,
same.
मतलब कि आपका SDN के अंदर कोई अंदर digester नहीं है तो कोई algorithm ही नहीं है।
Yes, sir. Different protocol, routing protocol use.
प्रोटोकॉल और algorithm को मिक्स मत करें, प्रोटोकॉल एक अलग चीज होती है। ठीक है, algorithm की बात कर रहा हूँ। digester को आप कंपेयर किसके साथ कर रहे हैं? वो algorithm है, that's not the protocol.
I implement register in this Rio controller for finding the shortest route between source and
सर
destination.
ने रियो और पॉक्स के ऊपर अलग-अलग क्या
अलग-अलग
इम्प्लीमेंटेशन की और दिखाया कि रियो तेज है कि पॉक्स तेज।
Box there.
ये नहीं बता रहे रजिस्ट्रार के अंदर क्या सीन है, रजिस्ट्रार को किसी के साथ मुकाबला कराना है वो नहीं बता
नहीं
रहे।
कर रहा है।
ये कह रहे हैं पॉक्स बेहतर है या रियो बेहतर है।
Rio.
लेकिन normal flow का मतलब क्या होगा?
Normal flow without register.
नहीं, normal flow का मतलब ये है कि spreading of messages जो कर रहे हैं,
Spreading, yes, sir.
flooding
Flooding technique is part. And
नहीं digestive के अलावा नहीं है, digestive के अलावा
Yes.
Bedman Ford use
वो
होता
तो
है।
बेशुमार और है, लेकिन
और-
वो
और है,
नहीं कर-
लेकिन maximum भी तक digester ही use होता है।
yes.
ये
And-
सिर्फ बता रहा है कि Fox दोनों में digester को measure कर रहे हैं
Yes.
कि Fox में digester कैसे behave करता है, उसका throughput किस तरह आता
ये
है।
सर की
और-
4 बजे क्लास भी है तो नहीं बोला
Yes, sir.
और-
आप जो है
And so I
कल
come
को कन्विंस करें कि यू आर
to the average
Qualified
throughput
for-
of Rio controller in Fox controller. Rio controller in register algorithm throughput is 7.166 and normal flow 4.96 and register in Fox controller 12.82 and normal flow 7.99.
What is the conclusion?
Conclusion is,
All
sir,
numbers.
in this slide I compare Fox in Rio SDN controller on the basis of throughput per
No.
network.
Conclusion means what this gives you a
Which
message.
one is better?
Fox is better in register
That's it.
algorithm.
Okay.
Okay.
That's
Fox
it.
is better.
ये प्रॉक्स बेटर है आप देखिए
Fox-
तो किधर से है? वो प्रॉक्स के तो वो ज्यादा बन थ्रूपुट
The throughput of Fox controller in register is 12.82. Is better according. Average throughput is
Okay.
better. Average throughput.
Okay.
And the Rio controller is 7.166.
Which is less. Okay.
Less, yes. This is the graph. From the graph, the x-axis show the time interval, y-axis show the throughput gigabyte per second. We can, according to the result of table and graph, we say the Fox controller in register algorithm has better performance in the term of throughput. In second slide, I want to check the PDR packet delivery ratio of Rio controller. Table show time interval total packet loss received in PDR between register algorithm and normal flow. The average I come to the average. Total packets, the register implementation in Rio is 89,000 and packet loss is 397 and received packet is 88,000 and the PDR is 99.54. Register in Fox total packet is 39,576 in normal flow 39576 and packet loss is 577 and receive packet 38999. Average PDR is 98. Now from the result of this PDR we can say the Digestra implementation in Rio is better than normal flow, because when implement Digestra a lot of packets in compared to normal flow. In normal flow 43,000 and with Digestra algorithm 89,000 packet sense. This is the graph of the Rio PDR. We can say Digestra algorithm in Rio has better performance compared to the normal flow in Rio controller. And second, the POX controller PDR. Table show time interval total packet loss received PDR of Digestra in normal flow. I come to the average total packet sent 76,000 and lost packet 15,000 and received packet is 75,000 and PDR is 97. And come to the normal flow 7,100 total packets 2,601 is the lost packets and 6,88891 is the receive packet. The PDR of POX controller without Digestra is 95 and Digestra PDR of POX controller is 97. Graph show the Digestra algorithm in POX has better than normal flow. In this slide, I compare the conclusion of POX in Rio PDR. In 1 second, the Digestra algorithm implementation in Rio PDR is 99.5, in normal flow 98.5, in Digestra in POX controller 97.336 and normal flow 95. From this result, we can see the Digestra algorithm implementation in Rio controller is better. In throughput parameter, POX controller was better. In PDR, Rio is the better. According to this table result and graph result.
So what is the overall conclusion?
Overall conclusion of two parameters remaining, sir. Overall conclusion is this.
ये तो हो गया ना, आगे जब
Yes, done. But go to the conclusion.
Next parameter which I select is jitter. Jitter means variation of end-to-end delay,
Which one is better?
and this is Rio is the better because the jitter is better than the POX.
Rio से आपने consider किया है the normal flow.
Rio only the jitter of Rio control is normal. In next slide I compare the POX and finally I compare from both POX and Rio. In this slide I compare Rio in POX controller jitter. In this slide the Rio Digestra algorithm in Rio controller network performance better than POX controller on the basis of this result. Show the
ये एवरेज बराबर कैसे होगी है? इसमें तो शुरू में बहुत फर्क आ रहा था, आखिर में बराबर हो गया।
Sergi average of the when we simulate this result for 10 seconds. In 10 seconds, how many average as an average how many packets in? What is the jitter in average second in this 10 second? The last one is packet loss of POX in throughput. Packet loss, how many packet loss when transmitting packet from source to destination? In this table, the Digestra algorithm implementation in Rio gave the result better compared to normal flow, Digestra and POX in normal flow of the POX. When we can see
बड़ा interesting है कि इसमें पैकेट लॉस ज़्यादा हो रहा है आपका जो flooding है उसमें तो चांसेस कम होते
कम
हैं।
होते यस
इधर आपने कहा कि चांसेस ज़्यादा हैं, ज़्यादा लॉस हो रहे हैं।
This is the graph of packet loss of POX in Rio throughput.
Can you come to the conclusion?
Yes.
Conclusion.
How many nodes did you use in your experiment, the results?
In 2 experiment I used.
Go to
One
your experiment.
ex-
Yes, how?
first in register I use 6 node.
6 nodes.
6 nodes.
Why so less?
We create custom topology of 6 node. Then implement register.
Why not 1,000 nodes?
I compare a lot of. Then for normal I use different nodes to check the
Why
result.
did you use different nodes for normal, but for digital you only use 6? Why?
Doesn't matter, sir. We can use.
It
I
doesn't
use.
matter.
It
I
does
use.
matter. Believe me, it does matter.
Matter, yes, sir. I use for my. I select different type of
But
simulation.
you haven't mentioned it here as well.
Yes, but the normal flow, for the normal flow, I select the standard topology when you give the comments. For standard topology, I select a lot of nodes compare.
Okay, and for
Yeah.
digital?
For the register, for the first time, I select 6 star. We can write the topology in Python as you wish. How much you want to add, you can add. In conclusion, implementation of register in POX in Rio controller. Rio controller is better on the basis of 3 parameters: PDR, jitter, packet loss. And POX controller is the better in throughput. In future work, we can use other shortest route algorithm in
What framework you suggest?
yes.
Whether to use Ryu or POX? This is the overall conclusion. What you suggest then?
I suggest Rio because PDR is better, jitter is better, and these are so better.
But
And
the throughput,
throughput
but
is
the
POX
throughput
better.
with the POX
POX
is
is
better, so
better.
we are normally looking to the throughput.
Throughput, yes. Throughput is a POX better. But compared to the result, Rio send a lot of packet record to POX controller. POX controller. In future work, we can use other controller and other register, other shortest route. For example, Bellman-Ford static algorithm instead of this algorithm to compare the result of this. This is the reference and questions.
I just have only one question.
Yes,
What does it mean normal flow?
normal
The
flow.
resistor is an algorithm.
Yes.
And normal flow is
So normal flow, you can flooding go from normal flow.
Flooding is normal flow without digital algorithm.
इंसान को इंसान से कंपेयर करते हैं इंसान को